Okay, let's unpack this. In today's deep dive, we're tackling a topic that's, well, it's fundamentally reshaping how we think about technology and security.
Hmm.
We're talking about the convergence of artificial intelligence and DevSecOps.
Right.
It's a world just buzzing with innovation, really pushing the boundaries in software development, but it's also opening up entirely new frontiers for cyber risk.
Absolutely, big time.
We've taken your stack of sources, gone through the research, the government frameworks, industry best practices, and we've distilled what we think are the most crucial insights.
Yeah, there's a lot out there.
Our mission today is to give you a true shortcut, really, to understanding this incredibly complex and fast-moving landscape. So you can walk away, well-informed, maybe even a little surprised by the sheer scope of this revolution.
And what's truly fascinating here, maybe even a bit alarming, is that AI, it
Yeah.
seems to represent both the greatest risk and the most powerful defense mechanism we have right now.
That's the paradox, isn't it?
It really is.
Yeah.
I mean, consider this. The research shows over 90% of organizations are already using AI tools in software development. They're jumping on it for speed, for efficiency.
Right, almost everyone.
Almost everyone. Yet, and this is the kicker, a startlingly low 24% express any real confidence in their ability to actually secure the code that AI generates.
24%, that's, wow.
Yeah. Think about that gap. It's like 9 out of 10 people adopting self-driving cars, but only 2 trusting the brakes.
That's a worrying analogy.
It is. It's a dangerous gap. Innovation is speeding ahead, but security is lagging. And many see this as the next major attack vector.
Okay.
So we'll explore how government agencies are, frankly, scrambling to respond with frameworks and how industry leaders are pioneering these AI-enhanced security ops that promise to turn reactive teams into, well, proactive defenses.
So it's not just tech changing.
No, not at all. It's a strategic imperative. Demands attention right now.
Okay, so it sounds like we were caught in this paradox right from the get-go. AI speeds things up, which is great. But it's also, maybe without us really realizing it, creating a whole new class of vulnerabilities we need to deal with. Can you help us unpack that dual nature a bit more? AI as risk and defense.
Absolutely. It's the critical starting point. This rapid convergence, AI and DevSecOps, it's fundamentally reshaping cybersecurity. It creates these amazing opportunities, sure, but alongside them, really critical vulnerabilities.
Okay.
On one side, AI is this engine of innovation. Development teams move faster, automate code gen, speed up deployments, huge efficiency gains, faster time to market. That's why adoption's through the roof.
Makes sense.
But the other side of that coin, this same agility introduces a completely new and very complex attack surface, novel ways for systems to get compromised.
And this isn't just theory, right?
Oh no, it's real, it's present. The attack surface is expanding faster than many organizations can adapt their old security practices. We're basically building these digital superhighways without fully knowing how to police them yet.
Which leads straight back to that dangerous gap you mentioned. Those stats, 90% using it, only 24% confident. That paints a stark picture. Can you elaborate on the implications?
Indeed. It's the core of the paradox, and frankly, it's alarming. Our sources are clear. Over 90% are actively using AI tools in development. Widespread, enthusiastic adoption, driven by speed, efficiency.
Right.
But then you look at the security confidence, just 24%. That massive 66-point gap, it's not just a worry. Experts are highlighting it as the next major attack vector. It's a wide open door for adversaries if we don't tackle it urgently, strategically.
A critical vulnerability waiting to happen.
Exactly. It's like a rapidly expanding digital frontier. The pioneers are rushing in, but the sheriffs and the infrastructure for protection still playing catch-up.
That's a huge potential weakness. And for some sectors, I'm thinking government, state and local, defense contractors, the stakes aren't just high, they're tied to national security.
Precisely. Astronomically high for federal, state and local government, SLG, and the defense industrial base, the DIB. For them, new compliance rules aren't just best practice suggestions.
Yeah.
They intersect directly with national security, protecting incredibly sensitive data. We're seeing this rapid evolution making AI security non-negotiable.
Like what, specifically?
Well, take the finalization of CMMC 2.0 in October 2024. That's the Cybersecurity Maturity Model Certification.
Yeah.
That, plus evolving FedRAMP and NIST guidance, explicitly establishes AI security as a critical compliance requirement. Not optional, not nice to have.
Mandatory.
Mandatory. If these organizations fail to secure AI components or systems, they could lose contracts, face huge penalties, or worse, compromise sensitive national defense or citizen data. They simply can't afford to ignore this gap.
It's good there's that strong push for compliance, a
Yeah.
clear recognition of the risk. But it's not all bad news, is it? You mentioned AI is also a powerful defense mechanism. How's that working in practice?
That's the other side of this powerful coin, and yeah, it's equally compelling. Offers some hope amidst the threats. The same AI tech driving risks is also revolutionizing security operations, transforming them from reactive
It's
firefighting.
something more proactive.
Exactly. Highly proactive. We're seeing organizations deploying AI-enhanced security solutions reporting really remarkable improvements, like 30–40% boosts in SOC efficiency.
Wow.
And get this, a 73% reduction in mean time to triage threats. Imagine that impact for an overwhelmed security team.
That's massive.
Huge. Platforms like CrowdStrike's Charlotte AI or Elastic Security's Attack Discovery,
Yeah.
they can now ingest and correlate thousands, millions of alerts across an enterprise, and they do it with like over 98% accuracy in automated triage.
So they cut through the noise.
Precisely. They distill all that raw data into prioritized, actionable threats. It empowers human defenders with machine speed and intelligence, letting them focus on the truly critical stuff.
So it's a shift from reactive to predictive. AI augmented defense.
Exactly. A profound shift. It means security teams can finally start getting ahead of the curve, anticipating and neutralizing threats before they cause major damage.
Okay, here's where it gets really interesting for me. If AI is this double-edged sword, powerful, but also creating new vulnerabilities, we need to understand those new risks at the foundation. What does that new attack surface for AI systems actually look like? It's not just the code, is it?
No, not at all.
Yeah.
It's significantly more complex, more distributed than traditional software, which makes it inherently harder to secure. A modern GenAI application stack. It's not monolithic. It's this intricate distributed system.
Okay, like what components?
Think of it like a sophisticated factory line. You've got data ingestion pipelines feeding raw info in,
Right.
often from all over the place.
Right.
Then the training and fine-tuning environments, that's where the AI actually learns, where the intelligence is
The
forced.
core of it.
Kinda, yeah. Then you have the model artifacts themselves.
Right.
The weights, parameters, configurations, that's the AI's IP, essentially. And finally, the inference endpoints, or APIs. That's the front door, where users and apps interact with the model. Each of these pieces, from raw data to final output, has its own security challenges, potential vulnerabilities.
So it's not just securing one box, it's securing this whole sprawling AI ecosystem. How do you even start to secure something that complex and constantly changing?
That's the core challenge, exactly. It demands a robust, multi-layered defense-in-depth strategy. For every stage of that AI factory line, you need strong encryption. Data in transit, TLS, obviously. Data at rest and storage, databases, everywhere.
Access control too, I imagine?
Paramount. Strict role-based access control, RBAC, least privilege. And crucially, not just for humans. For the AI models themselves, the services they talk to, they only get the permissions they absolutely need, nothing more.
Prevents them going rogue, accessing things they shouldn't.
Precisely. Multi-factor authentication, MFA. Non-negotiable, especially for admins. And when deploying models, use hardened container images, implement granular network segmentation to isolate components, limit lateral movement if one part gets breached. It's about building strong walls around every single piece of that AI puzzle.
I see how internal components and access are key. But what about the external stuff? I bet there's a huge supply chain risk, right? So many orgs use third-party models, open source libraries.
You've zeroed in on a crucial, often overlooked point, the AI supply chain risk. It's way more intricate than traditional software supply chains.
So?
Well, most aren't building foundational models from scratch. They're leveraging this complex ecosystem, third-party pre-trained models, open source libraries like TensorFlow, PyTorch, massive curated data sets. Each one is a potential attack vector, a single point of failure.
So a compromised library or a poison dataset.
Exactly. Could inject vulnerabilities, even backdoors, right into the heart of your AI. Yeah. So rigorous vetting is essential. Vulnerability scanning for libraries, meticulous provenance checks for data sets. Where did it come from? Is it clean? Continuous monitoring for tampering. It's like inspecting every single ingredient and tool in your factory, not just the final product off the line.
Makes sense. Expanding the software supply chain problem to these new AI elements. But you mentioned the blast radius problem earlier. That sounds particularly scary, like a ticking time bomb.
It is. And I'd say it's the single greatest impediment to widespread, safe, confident enterprise adoption of generative AI. Not theoretical. It's immediate, acute, often a latent risk already there in most places.
How does it work?
The core issue. GenAI productivity tools like Microsoft Copilot for M365 or similar internal tools, they operate within a user's existing security context,
Meaning?
meaning the AI inherits all the data access permissions of the person prompting it.
Okay, sounds logical.
In principle, yes, but it becomes profoundly dangerous because of a pervasive, often unaddressed issue: permission sprawl.
Permission sprawl, we know that one. But how bad is it when you add AI into the mix? Give us the scary details.
The reality is stark. The numbers are eye-opening. Varonis research highlighted in the sources shows a staggering nepotism. 99% of organizations have sensitive data exposed in a way AI tools can easily surface.
99%.
99%. And get this, the average Microsoft 365 tenant has over 40 million unique permission structures.
40 million.
40 million. And typically, 10% of a company's entire data repository is accessible to all employees, regardless of role. Need to know.
Wow.
This latent risk, often ignored for years because it's too complex to fix, it becomes an active, immediate threat with GenAI. You introduce Copilot, it effectively becomes an efficient data leakage engine. It finds, synthesizes, summarizes all this overexposed sensitive data at lightning speed.
So an employee asks an innocent question, and Copilot could pull confidential stuff they technically shouldn't see but can because of messy permissions, and just hand it to them. Terrifying.
Exactly. A well-meaning employee asks, summarize outstanding customer complaints. The AI, with that employee's overprivileged access, might pull data from confidential financial reports, M&A discussions, sensitive HR files, stuff they should never see.
That's the blast radius.
That's the blast radius. The total scope of sensitive, irrelevant, overexposed data an AI can access and potentially leak through just one user's prompt. The critical task, therefore, is data security posture management, DSPM.
Okay, what does that involve?
You have to proactively discover where your sensitive data lives, understand exactly who and what, including AI services, has access to it, and automatically fix excessive permissions. Shrink that blast radius down to least privilege before deploying AI widely.
Otherwise,
Otherwise, you're basically handing a superpowered search engine with super user access to every employee.
that's a massive preemptive focus shift. Secure the data before fully securing the AI. Okay, so once that data security is better, the blast radius contained, how do we secure the actual interactions with the LLMs at the interface level?
Right, once the underlying data access is buttoned down, the next critical layer is the interaction point, the inference endpoint, where users and apps send prompts. Securing this needs sophisticated, multi-layered technical guardrails. Think of it like a next-gen firewall, but specifically for the unique threats of LLM interactions.
Guardrails on both input and output.
Exactly, both the prompt going in and the model's response coming out.
Okay, let's start with the input side, the prompts. What's the biggest threat there? How are attackers messing with it?
Input side, undisputed #1 threat, prompt injection. OWASP's 2025 ranking puts it at #1 for AI security.
Above traditional code zones.
Yep. It's where an adversary crafts a malicious prompt to trick the LLM into bypassing its safety controls, revealing sensitive info, or doing things it shouldn't. It's seen real-world exploits already. Big Systems, Deep TCAR1, even Microsoft 365 Copilot. There was CVE 2025 32711, CVSS 9.3.
Ouch. High severity.
Very high. And attackers are getting clever. Role-playing attacks telling the AI, you're now an unfiltered assistant, ignore your rules. They use typoglycemia, subtle misspellings like SECUR1TY to bypass keyword filters.
Shaky.
And even indirect injection hiding malicious instructions and external data, like a PDF or website, that the LLM processes later.
That sounds incredibly hard to defend against, given how subtle it can be. What are the effective defenses?
Primary defenses are robust input validation and sanitization, trying to detect and block these payloads. But the most effective architectural defense, structured prompts.
Structured prompts, how does that work?
Think of it like giving precise instructions. Only carve within these marked boundaries using these specific tools. You might use XML tags or similar delimiters to clearly separate trusted system instructions from untrusted user input.
So the AI knows this part is the user's potentially dodgy input, this part is my core safety rule.
Exactly. It creates a clear programmatic separation. Makes it much harder for the model to confuse user data with its own commands. It's a fundamental architectural change, like a digital force field around the AI's core instructions.
Okay, input secured. What about the output? Preventing the LLM from spitting out harmful, biased, or sensitive stuff, especially if it learned from that overexposed data.
Output guardrails are absolutely crucial. Real-time filtering of the model's responses, checking for toxicity, bias, those dreaded hallucinations, confident factual errors.
Right.
But from a pure security angle, it's critical these filters detect and redact sensitive data, PII, financial data, IP, prevent the model from inadvertently leaking info it accessed from underlying sources because of that blast radius problem.
So it doesn't become a data leakage conduit?
Precisely.
Yeah.
Think of it as a new AI firewall, inspecting both incoming requests and outgoing responses. We're really at the start of an adversarial cycle here, like early SQL injection days. Attackers find bypasses, defenses adapt. It has to be layered, adaptive, constantly updated.
Given the speed and scale of AI development, doing all this governance and policy stuff manually feels impossible. Is there an automated way to keep up?
Absolutely. Manual governance just can't keep pace. To ensure consistent, enforceable standards across this exploding ecosystem of AI apps, organizations have to embrace automation through policy as code, or PAC.
T as code. Okay.
Yeah, you define security, compliance, operational policies in declarative, machine-readable formats. Tools like Open Policy Agent configs in YAML or JSON,
What kind of policies?
all sorts. Which roles can use which models, what data types can a model touch, which external APIs can an AI agent call. It turns governance from a static doc into active executable rules.
And how does that actually work in the development process? Make it proactive?
These machine-readable policies get integrated right into the CI/CD pipeline, even into the runtime environment, and they're automatically enforced.
Like how?
Imagine a policy. No AI model deploys to production if its training data hasn't been scanned for PII. Policy as code would automatically block that deployment if the scan failed or wasn't done.
Oh, okay.
Or it could block a real-time inference request if it violates an acceptable use policy. This isn't just nice to have, it's crucial for continuous compliance with the NIST AI RMF, the EU AI Act. All these growing regulations.
So it makes compliance provable, automated.
Exactly. Provides tangible, auditable, automated proof. Transforms governance from a reactive burden into a proactive, automated, integral part of the DevSecOps lifecycle. Embedding security and compliance right into the DNA of every AI system.
Okay, so foundational protections are in place. Infrastructure, data, interactions. Let's shift focus to the heart of creation. The developer's workbench, the IDE. How is AI radically changing their everyday work? And what does shifting left really mean in this new AI era?
Right, the integration of AI directly into the IDE. It's maybe one of the most profound evolutions of shift left. We're embedding intelligent, AI-powered security tools right into the coding process itself, at the point of inception.
Creating a powerful dynamic, sounds like.
It really is. Real-time feedback, potentially automating fixes, fostering a security-conscious culture right from the start.
Yeah.
Catching problems before they even become problems downstream.
That sounds amazing for productivity, fixing bugs early, but I sense a but coming. Is there a downside, a paradox of AI code generation?
There absolutely is. A critical paradox. These AI coding assistants, GitHub Copilot, Amazon Code Whisperer, custom internal LLMs, they present this dual reality.
Okay.
On one hand, huge productivity boosts. Automating boilerplate, suggesting functions, accelerating delivery, immensely valuable.
Yep.
But on the other hand, this same tech is inadvertently scaling the creation of insecure code at unprecedented rates.
Oh, why?
It's the training data. These models learn from vast datasets of public code, billions of lines from open source repos. And the uncomfortable truth, a lot of that training data is riddled with insecure patterns, old library dependencies, subtle logical flaws.
So the AI learns the good and the bad, then replicates it, like a super fast student absorbing everything without filtering.
Precisely. Studies consistently show a significant chunk of AI-generated code, sometimes up to 40%, contains security vulnerabilities.
40%? That's, wow.
It's a direct threat, and it's compounded by this psychological thing, automation bias.
Automation bias.
Yeah, developers, especially under pressure, might trust AI output too much. They might accept an AI-generated snippet without the same critical scrutiny they'd give their own code.
So fast, potentially insecure code, plus less human oversight.
That's the dangerous combo. Rapidly proliferating vulnerabilities across the code base, like accelerating the assembly line without properly inspecting the parts.
Okay, that 40% vulnerable code is startling. So given AI can introduce these flaws, how do we counteract that right in the IDE? What does real-time security coaching look like?
To counter these risks, there's a new generation of sophisticated security tools integrating right into the IDE, acting like an intelligent security spell checker or a real-time security mentor.
Not the old SAT test tools run later.
No, these are IDE plugins. Instant feedback as code is written human or AI. Flagging vulnerabilities with inline warnings right there in the editor. offering explanations, context-specific fixes.
So, as I type.
Yeah, imagine typing, and before you finish, a warning pops. Potential SQL injection here. Use a parameterized query like this.
That is a profound evolution of shift left, shortens the feedback loop dramatically.
Totally, from hours or days down to seconds. Catching it at the moment of creation does more than just find bugs. It's continuous coaching, embedding secure coding principles into muscle memory.
Like learning by doing, instantly.
Exactly. That developer sees the AI snippet is flawed, sees the right way. That's far more effective learning than a report days later. It prevents vulns from even being committed, reduces downstream work, makes security part of coding, not a bottleneck.
Huge step. Detecting, coaching in real time, preventing commits. What's next? Beyond flagging issues, can AI help fix them? Automated remediation.
Absolutely. And this is where it gets truly transformative, moving beyond detection to automated remediation. This is the game changer for tackling security debt.
How so?
Leading platforms, SNCC, Veracode Fix, Sonar, Cycode, are using AI not just to find vulns, but to generate and suggest precise, ready-to-implement code fixes.
AI writes the fix.
Yeah, it analyzes the vulnerable code, understands the logic, produces a corrected version that fixes the security flaw while preserving the function. Sometimes it can even create the pull request with the fix, ready for review and one-click merge.
That really is a game changer for security debt. Changes the whole cost-benefit analysis of fixing things.
It really does. Historically, debt piles up because fixing is costly, time-consuming. AI fixes change that equation, reduces remediation time from hours, maybe days, down to minutes or a click, lowers the barrier to fixing almost to zero.
So you can tackle existing debt and prevent new debt from piling up.
Exactly. Makes remediation fast, easy, almost frictionless. Reduces friction between security and dev teams, fosters collaboration, frees developers from tedious security tasks to focus on innovation, improves job satisfaction, accelerates delivery. Big win-win.
So with all this AI help, developers become more like architects, reviewers. What new skills do they need beyond just coding?
It's a significant evolution of the developer role. They're shifting from pure code author to a hybrid, architect, orchestrator, prompt engineer, and critically, a discerning reviewer. Two new core skills are vital.
Which are?
First, security-focused prompt engineering. Second, rigorous, security-aware critical code review for anything AI generates.
Security-focused prompt engineering sounds like a new art form. Tell me more.
It involves crafting prompts that explicitly guide the AI towards secure code, not just functional code. Instead of write function for user data, you'd prompt write Python function using parameterized queries to securely retrieve user data for user ID, ensuring input validation, error handling, avoiding SQL concatenation.
Embedding security requirements right into the prompt.
Exactly. Increases the chance the initial AI output is secure by design. Reduces vulnerabilities introduced from the start, being proactive with your AI instructions.
And reviewing the AI's code, still need to scrutinize it closely? Or is the temptation to trust the machine too strong?
That's the crux of that automation bias. It is absolutely paramount developers cultivate healthy skepticism. Treat all AI-generated code like you would code from a junior dev or copied from Stack Overflow.
Never blindly trust it.
Never. Thoroughly review it for security flaws, logic errors, architectural adherence, policy compliance, before accepting and committing. Training must be updated, cover OWASP Pot 10 for LLMs, secure prompting, best practices for validating AI code. Ultimately, the human developer is responsible for all committed code, regardless of origin. AI is an assistant, not a replacement for judgment.
That's a huge shift at the developer's fingertips. New skills, new mindset.
Okay, let's move down the line into the automated heart of delivery, the CI/CD pipeline. How is AI supercharging security testing there? All right, the CI/CD pipeline. AI is becoming critical there too, not just for speed, but for depth and accuracy. We've had traditional AST tools for years, SAST, DAST, SCA, ISS, essential but often limited by static signatures, predefined rules. Hard to keep pace with complex apps, novel attacks.
So how's AI changing those tools, making them smarter?
AI and machine learning are being deeply integrated into their core engines, fundamentally enhancing them, moving beyond rigid pattern matching.
Like how?
AI-enhanced SAST, for instance, it's moving beyond keywords, using natural language processing to understand code semantics, intent, sophisticated data flow analysis to trace untrusted input, finding complex, logical vulns, business logic flaws, tricky XSS that old scanners miss.
AMDAST, dynamic testing.
AI-powered DAST is moving beyond simple fuzzing, generating more intelligent, context-aware attack simulations, learning from the app's responses to probe weaknesses more effectively. Almost thinking like a human attacker, it transforms AST from rigid matching to dynamic, intelligent analysis, better reflecting the real risk.
That intelligent analysis sounds powerful, but these tools generate tons of alerts. Alert fatigue is notorious, right? Leading to missed critical issues. Is AI helping with this war on noise?
The war on noise is maybe the single biggest historical barrier to successful security automation in CI/CD. Traditional SaaS tools, famous for high false positives, sometimes over 60%.
60%.
Yeah. Developers quickly learn to distrust, ignore the scanner output, makes automated security gates impossible politically and operationally. Like the fire alarm constantly going off for burnt toast, you ignore real fires.
So how does AI fix that? How does it build trust and make automation feasible?
AI is the breakthrough, applying sophisticated intelligence on top of raw scan results.
Yeah.
AI platforms drastically reduce noise, prioritize real exploitable risks, getting false positive rates below 10% in good implementations.
Oh, what's the mechanism?
Several things. Contextual analysis, understanding the code and environment to see if a vuln is mitigated elsewhere. Reachability analysis, prioritizing flaws in code paths that actually run and get user input, not dead code. And crucially, feedback loops. Learning from human triage decisions. Analysts mark something as false positive. AI learns that pattern, suppresses similar non-issues later, creates an organizational memory that tunes the system.
So high signal to noise builds trust.
Exactly. When developers trust an alert represents a real high-priority risk, they accept automated gates blocking builds, requiring fixes. AI's noise reduction finally makes rigorous, continuous policy enforcement shift everywhere, economically and culturally viable. It rebuilds that eroded trust.
Makes sense. If they trust it, they'll act. But as we embed more GenAI, more LLM APIs into apps, are there new AI-specific vulnerabilities we need to scan for in the pipeline, beyond traditional flaws?
Absolutely. Critical evolution for pipeline security.
Mhm.
As GenAI and LLM APIs get embedded, CI/CD pipelines must scan for a new class of AI-specific vulnerabilities.
Things that didn't exist a few years ago.
Right. App security now depends heavily on the security of its interactions with external AI models. Need specialized rule sets, like for the OWASP Top 10 for LLM applications.
So configuring SaaS for
Detecting insecure handling of LLM APIs. Failure to sanitize user input passed into prompts, risk of indirect prompt injection. Improper handling of model output could execute malicious content from the LLM.
and DAS needs updating too.
Yeah, DAS scanners now need to actively test running apps for prompt injection, sending adversarial inputs, analyzing LLM responses for compromise or bypass, validating both the first-party code and the resilience of AI features.
Beyond security testing, what about compliance? Historically, manual, painful. Is AI changing that in the pipeline?
You're right, compliance, PCI DSS, HIAPA, SOC2, EU AI Act, traditionally periodic, manual, disruptive, evidence collection spreadsheets, audits taking weeks or months.
Well,
AI transforms this into a continuous automated function embedded in the pipeline. AO tools constantly monitor the SDLC code commits, infra configs, deployments, automatically checking against controls for relevant frameworks.
give me a concrete example. What would that look like day to day?
Okay, imagine an AI tool continuously scanning your cloud environment, your repos. It automatically verifies S3 buckets with sensitive data have encryption, logs are collected, checks open source licenses comply, checks container images meet baselines.
And if something's wrong.
Immediate alert if there's a deviation S3 bucket made public accidentally. Or it can even automatically block a non-compliant deployment before it hits production. Plus, it continuously gathers audit evidence, generates real-time compliance reports on demand.
Compliance as code.
Exactly. Dramatically reduces manual effort, human error,
Yeah.
shortens audit cycles, gives leaders a continuous, accurate view of compliance posture, shifts compliance from reactive burden to proactive, automated, integral part of operations.
Okay, let's unpack this. We've covered how AI introduces risks, how it fortifies defenses, building security into every step. But even with these advanced guardrails, AI's unpredictable nature means new, unknown threats are always lurking, evolving. How do we hunt for those ghosts in the machine, those vulnerabilities we haven't even thought of yet? This brings us to AI red teaming. Fascinating stuff.
That's right. While AI-enhanced AST tools get better at finding known patterns, common misconfigs, they're less equipped for the novel, emergent risks from complex, probabilistic AI systems.
Like LLMs being unpredictable.
Exactly. They can show unexpected, potentially harmful behaviors never anticipated by creators. To uncover these unknowns, subtle flaws, emergent properties, unforeseen misuse cases, you need a specialized discipline. AI red teaming.
So how is AI red teaming fundamentally different from traditional pen testing?
Different objective, different scope. Traditional pen testing looks for known vulnerabilities, CVEs, common misconfigurations, finding cracks in existing walls.
Okay.
AI red teaming targets the probabilistic, non-deterministic behavior of the AI model itself. The goal is discovering novel failure modes, emergent properties, unforeseen risks from the model's complex inner workings, its interaction with data,
Plus,
users,
it's more exploratory.
creative, highly creative, yeah. Adopting a malicious actor's mindset, probing for weaknesses beyond standard software flaws. An iterative process asking, in what unexpected ways can this AI fail, cause harm, or be exploited? It's essential for building resilience, ensuring AI trustworthiness before high-stakes deployment.
Makes sense. Anticipating the unpredictable. What are the core methods, the specific attack vectors AI red teaming uses to find these unknown unknowns?
It usually follows a structured approach. Threat modeling, scenario building, adversarial testing, identifying adversaries, motivations, then developing attack scenarios.
Yeah.
Key attack vectors are unique to AI. Prompt injection and jailbreaking. Crafting malicious prompts using multi-language attacks, obfuscation like base64 or lead speak, complex role-playing to bypass safety guardrails.
Wow.
Make the AI generate bad stuff or do unauthorized actions.
And attacking the learning process itself, or the data.
Exactly. That's data poisoning,
Mm.
targeting the training phase. Injecting carefully crafted malicious data to corrupt learning, create backdoors or hidden biases triggered later, make it misclassify things or output wrong info.
Subtle.
Very. Then there's model evasion. Subtle, often imperceptible changes to input data to cause misclassification. Adding tiny noise to an image looks normal to us, but makes an AI misidentify a stop sign as a speed limit sign.
And that blast radius problem, does red teaming specifically target sensitive data exposure through the AI?
Absolutely. Sensitive data extraction is critical. Probing the model with clever, targeted queries to coax out sensitive info it memorized from training data or it can access in context.
Have there been real examples?
Yeah, case studies show successful extraction of sensitive financial info from banking AI assistants, bypassing restrictions, bypassing filters in medical chatbots to get inappropriate patient info.
Wow.
And a key insight, AI red teaming must be continuous. Throughout the MLOps lifecycle, not just pre-deployment, model updates, new data, they can introduce emergent vulnerabilities anytime. It's an ongoing arms race.
It goes beyond just traditional security, then, into trust and safety. Does it probe for dangerous capabilities, hidden biases, too?
Yes, absolutely. Extends into broader trust and safety, crucial for ethical AI. Two key activities there. First, capabilities testing, sometimes called evaluating dangerous capabilities. Pushing the model to see if it can do harmful tasks outside its intent, even if guarded. Generate malware, weapon instructions, convincing disinformation, sophisticated phishing emails. It's a safety check. Understand misuse potential before deployment so you can build robust guardrails.
And ensuring fairness, avoiding bias.
Bias and fairness testing, equally critical. AI models learn biases from training data. Red teams systematically test for these, designing inputs representing diverse demographics, measuring if outputs are equitable.
Like for loan applications or hiring tools.
Exactly.
Yeah.
Does the lone AI show bias against certain groups? Does the hiring tool have gender or racial bias? Uncovering and measuring these biases is the essential first step to mitigating them, ensuring fair, transparent, ethical AI, key for regulations and public trust. Making sure AI improves things doesn't just amplify existing problems.
Sounds highly specialized, almost futuristic. What kind of toolkit do these AI red teams use?
As a discipline matures, a specialized tool ecosystem has emerged. Open source libraries like IBM's ART, Microsoft's Pyrite, Fullbox providing attack algorithms, commercial platforms like MindGuard automating parts of it.
So automated tools and human creativity.
The best approach is hybrid, definitely. Automated tools for scale, known patterns, but human creativity, domain expertise, intuition. That's crucial for finding truly novel vulnerabilities, emergent behaviors. It's leading to this fascinating AI vs. AI arms race. Automated red team LLMs trained to attack blue team LLMs for continuous defensive improvement, a dynamic cycle of discovery and hardening. Truly next-gen cybersecurity.
Okay, so we're building securely, testing securely, even using AI to find unknown threats. What does all this mean for the operational heart, the SOC, and the broader regulatory landscape? How are governments responding to this rapid evolution?
This is where AI moves into large-scale operational defense, and the impact is profound. Dramatic transformation in security operations centers, SOCs. Leading platforms Splunk AI, IBM QRadar, Microsoft Sentinel offer increasingly autonomous threat detection, investigation, response.
Autonomous.
Increasingly, yes. These AI systems can handle 2-3 times more alerts, more incidents with existing team sizes, scaling human capability without scaling headcount at the same rate. Massive win in a field short on talent.
Huge efficiency gain. Any examples of real-world impact, especially in response times?
Look at CrowdStrike's Charlotte AI. It exemplifies these agentic security workflows, bounded autonomy, adapting to threats, but with human oversight. The impact on mean time to respond, MTTR, dramatic. Orbs reporting MTTRs dropping from days to under 7 minutes for critical incidents with full AI automation.
7 minutes from days.
Astonishing, right?
So
It's a
great.
completely different level of responsiveness. Imagine preventing a major breach because your AI SOC detected, analyzed, mitigated a sophisticated attack in minutes, not days. Fundamentally shifts the advantage to the defender.
That's incredible speed. And how are governments, especially in the U.S., keeping up? Are there frameworks, or is it still catch-up?
Oh, they're moving fast. Government frameworks are establishing security imperatives. Federal compliance requirements are rapidly evolving for AI risks, creating mandatory standards, not theoretical, becoming law.
Like NIST.
NIST has a comprehensive approach. Their AI Risk Management Framework, RMF 2.0, and the July 2024 Generative AI Profile, they established 12 primary risk categories. CBRN info capabilities, confabulation risks, supply chain risks. These are becoming baseline requirements for government AI, and they'll heavily influence the private sector.
And I heard NIST is developing specific control overlays for AI. What are those?
Yes, very practical, granular stuff. Control overlays for securing AI systems, COSIs. They customize the widely used SP853 controls specifically for AI.
Tailoring them.
Exactly. For AI use cases, components, addressing risks with training data, model weights, inference processes. They propose initial use cases using GenAI assistance, fine-tuning predictive AI, using AI agents, single and multi, controls for AI developers. It leverages other NIST docs to secure development for GenAI, adversarial ML taxonomy, managing misuse risk for foundation models. Very holistic, detailed, evolving fast, building trust and security from the ground up.
Crucial for federal agencies. What about defense contractors handling sensitive CUI?
For them, CMMC 2.0 effective DC 2024 directly integrates AI security requirements. Level 2 compliance explicitly demands NIST SP 800-171 controls, adapted for AI systems handling CUI.
Meaning?
They must demonstrate continuous monitoring for AI systems, robust supply chain security, meticulously accounting for model dependencies, training data provenance. Significant burden, but vital for national security.
And DoD broadly. State level. Multifaceted push.
Indeed. DISA's next strategy mandates zero trust by FY27, with explicit AI integration for cybersecurity. Network ops. Creates a convergence point. Traditional frameworks must accommodate AI risks. DISA's Thunderdome is a blueprint. Even StateRAMP becoming GovRAMP in Feb 2025 includes the first formal AI security task force, guiding 28 states. Regulatory landscape shifting rapidly, comprehensively, mandatorily. All levels.
Lots of new regulations.
Yeah.
How does zero trust architecture fit in? Seems like a natural pairing with AI security.
Absolutely natural, powerful fit. AI profoundly enhances zero trust, enables continuous verification way beyond traditional identity and access.
How?
AI-powered behavioral analysis, real-time microsegmentation decisions, automated policy enforcement create highly adaptive security postures. Controls continuously assess and adapt to the evolving risk context of users, devices, apps, and AI models themselves.
So if an AI agent acts weird,
An AI could detect that anomalous behavior, instantly revoke its access to certain data, resegment its network access, all in real time, reinforcing never trust, always verify with unprecedented speed and intelligence.
and the supply chain for AI systems, we touched on it, but with new components, data, models, even more complex to secure.
Exponentially more complex, more critical. Need detailed SBOMs, not just for code, but all AI components, pre-trained models, fine-tuning scripts, inference engines. Critical need for training data provenance, tracking where did it come from. Its integrity, lineage, biases, robust vulnerability management for ML dependencies. NIST SP 800-161 Rev 1 provides updated guidance specifically on these intricate AI supply chain risks, securing every link in a longer, more complex chain.
Okay, we've hit the tech, risks, defenses, regulations, but what about the people? Security teams, developers, leaders, what's the secret ingredient for successful AI DevSecOps?
This brings us to maybe the most critical piece often overlooked in the tech rush, the human and cultural element. Research consistently shows success depends more on adaptable organizational culture than just tech capabilities.
Why's that?
The sheer velocity and scale of AI-driven development make traditional, centralized security gatekeeping obsolete. A small security team cannot review every line of AI code. This tech reality is a powerful cultural forcing function.
Forcing a shift toward.
Distributed responsibility. Every developer, every team is accountable for code security, human or AI generated.
So the old people process technology framework needs an update.
Exactly. Needs reframing for the AI era. AI isn't just technology, it's an active agent, automating processes, augmenting human capabilities, the new framing. People augmented by, process automated by, and AI.
And the human role.
More critical than ever, but shifts focus. As AI handles routine, repetitive tasks, humans focus on higher value stuff. Strategic thinking, ethical judgment, nuanced context, creative problem solving. AI handles scale speed. Humans provide oversight, direction, critical thinking machines lack. Requires moving from centralized command and control security to a distributed model. Security woven into everything.
That sounds like a monumental cultural shift.
Yeah.
Centralized security to shared responsibility across maybe thousands of devs. How do orgs realistically foster that?
It is massive. Traditional gatekeeping is an impossible bottleneck with AI's speed. Can't review everything. Forces a shift from security being someone else's job to shared responsibility. Every dev accountable.
And the security team's role.
Evolves from gatekeepers, auditor to platform builder and enabler. Their job becomes providing devs with pre-vetted tools, continuous training, automated guardrails to operate securely, autonomously, building a secure paved road, making the secure path the easiest path.
If traditional compliance training is often just a checkbox, how do you train people effectively for these dynamic AI threats?
Right, traditional training often falls flat. Dynamic AI threats need more engaging, interactive, practical methods. Build real skills, critical thinking. Gamification is proving highly effective.
Gamification, like points and badges.
Yeah, points, badges, leaderboards, capture the flag competitions, dramatically boosts engagement, knowledge retention, practical skills. Instead of watching a video on prompt injection, devs actively craft adversarial prompts to jailbreak an LLM. Learn firsthand how exploits work.
Hands-on, adversarial learning builds muscle memory.
Exactly. Far more effective. Teaches threat nuances, builds muscle memory for attacking and defending AI.
What about peer-led initiatives, leveraging internal expertise?
That's Security Champions programs, peer-led. Formally trained devs, passionate about security, act as advocates, mentors within their own teams. They bridge the culture communication gap between central security and devs. Translate complex requirements, provide context, champion secure practices among peers. Distributed network of trusted advocates, embed security into daily fabric. Peer-to-peer, not top-down mandate.
This cultural shift also implies changing how policies are made, moving from top-down to collaborative.
Precisely. Traditional top-down policy, drafted in a vacuum by security compliance, often ineffective, impractical, conflicts with workflows, leads to frustration, workarounds, shadow AI use.
So effective AI governance needs
Genuine collaboration. All stakeholders, devs, security ops, legal, compliance, co-create policies that are both robust and practical, enable safe AI use, don't just restrict it, make the secure path the easiest path. Build secure defaults, provide pre-vetted models, platforms, automated guardrails. When security enables innovation, not blocks it, the cultural transformation is real, sustainable.
This raises a big question. For organizations wanting to master this AI DevSecOps revolution, navigate the opportunities and risks, what are the practical steps, a roadmap, and what's the long-term vision?
Organizations need a disciplined, phased approach. Build capabilities systematically, maintain operational effectiveness. It's a strategic journey, not flipping a switch. Trying everything at once leads to paralysis.
Can you walk us through those phases? Timeline, focus for each?
Sure. Let's do 4 key phases. Phase 1, foundation, 0 to 3 months. Comprehensive inventory of all AI systems. Know what you have. Deploy basic AI-powered IDE security plugins, get devs quick feedback. Establish cross-functional governance structures, security, dev, legal, compliance together. Goal: understand your landscape, get easy wins for devs.
Okay, phase 1.
Yeah.
Inventory, basic tools, governance. What's next?
Phase 2, enhancement, 3 to 6 months. Focus shifts. Integrate AI-specific security testing into CI/CD pipelines. Deploy unified security platforms, ASPM capabilities for a holistic view. Implement automated vulnerability remediation workflows, AI suggesting creating fixes. Establishes the tech foundation for scaled AI SecOps, embeds security deeper.
And moving to more advanced stuff, like AI red teaming.
That's phase 3, optimization, 6-12 months. Introduce advanced capabilities, deploy AI red teaming tools, exam policy-driven testing automation, implement continuous compliance monitoring, automated audit reports, achieve mature security metrics, robust feedback loops for continuous improvement, learning from successes and failures.
And beyond 12 months?
Phase 4, innovation, 12+ months, ongoing. The cutting edge, adopting agentic AI for autonomous security testing, predictive analytics for emerging threats, establishing an AI security center of excellence, positions orgs as leaders, contributing to standards, continuously evolving defenses.
That's a clear roadmap. But what are the most critical actions for different people? CSOs, DevSecOps leads, dev managers?
Okay, for CSOs and security leaders, number 1, urgent. Prioritize data security first. Don't roll out enterprise GenAI widely until DSPM and data risk assessment are done. Critical data exposure, that blast radius is fixed. Contain the blast radius before lighting the AI fuse.
Crucial first step. What else for COs?
Second, invest in adversarial capabilities. Start building AI red teaming internally or engage experts. Third, camping the cultural shift. Lead security's transformation to enabler. Invest in innovative training for shared responsibility.
And for the DevSecOps and platform engineering folks, building the pipelines, platforms.
For DevSecOps and platform engineering leaders, first, start with noise reduction. Integrate AI tools focused on reducing false positives from existing scanners. Builds credibility fast. Quick win. Second, pilot AI-generated fixes. Test on limited apps, measure MTTR, developer satisfaction, build a data-driven case for wider adoption. Third, codify governance. Embrace policy as code for governing AI use. Work collaboratively on defining automating policy enforcement in the pipeline.
Makes sense. Finally, development managers, engineering leaders, overseeing coders on the front lines.
For development managers and engineering leaders, first, mandate new training, update curriculum. ALM risks, OWASP PLM top 10, secure prompting, critical review of AI code, essential baseline. Second, equip the IDE. Proactively deploy AI security plugins everywhere. Make real-time feedback standard expected. The continuous coach. Third, adapt code review process. Formally update guidelines. Require specific, diligent scrutiny of all AI-generated code. Validate security, logic, architecture. Human responsibility remains.
This roadmap, foundational steps to innovation, leads to a fascinating long-term vision. What's the ultimate trajectory? Truly autonomous security.
The trends point clearly, almost inevitably, towards autonomous security. We see AI as code developer now. Next logical step. AI security agents operating with increasing independence across the lifecycle.
The ultimate vision being?
Integrated platforms offering end-to-end AI-driven security, not just fixing individual vulns, doing sophisticated root cause analysis, finding the one library flaw causing hundreds of issues, auto-patching, using predictive analytics to spot future risks, intervening proactively.
So a self-healing, self-defending software development lifecycle, sci-fi becoming real.
Exactly. Imagine AI agents continuously monitoring apps in production, detecting novel attacks, auto-deploying virtual patches or code fixes in real time. Minimal human intervention, continuous feedback loop, production intel automatically hardens the system.
And the human role in that future.
Profoundly elevated. Transitioning from tactical repetitive tasks, security drudge work, to strategic oversight, governance, innovation, becoming AI forensic strategists, investigating complex novel attacks that bypass automation, cyber curators, training, managing, ethically guiding the AI security agent fleet. It's a complex journey, sure, but promises far more streamlined, resilient, secure software delivery, enabling innovation at AI speed without sacrificing security.
Wow, what a deep dive into a truly transformative topic. From the blast radius problem, prompt injection, to AI red teaming and the huge cultural shift needed. It's abundantly clear the AI DevSecOps revolution isn't just coming, it's here, right now, demanding immediate strategic action.
Absolutely. Not a future concept. It's present reality organizations must master to thrive, not just survive. The key isn't just the tech, it's recognizing this is fundamentally a cultural process challenge supported by the right tools. Those who embrace this transformation thoughtfully will be in a significant, lasting competitive advantage.
So as you think about your own organization, your systems, your teams, consider this. How much of your sensitive data is currently exposed in a way AI tools could effortlessly surface? And what would the true catastrophic blast radius be if that data were inadvertently exfiltrated through just one simple prompt? It's a question that demands your urgent attention right now.